All right, 16.2, solving exponential equations, day 2. We got word problems. Suppose that 250 is deposited into an account that pays 4.5% compounded quarterly. The equation A equals P times 1 plus R over 4 to the n, given the amount A in the account after n quarters for an initial investment P that earns an interest rate of R. Our job is to solve for n to find out how long it will take the account to contain at least $500. So we're going to solve it for n. N is your exponent, which means we should be thinking already we're going to have to take logs. I don't see e in here anywhere. That means that we're not going to use the natural log. We're going to take the log of both sides to get n out of there. But first, let's identify some of our givens. So here's our formula. I wrote it up here. And we need to know what P was. What was the initial investment? That was 250. And R, the interest rate. The interest rate was 4.5%. If I change that to a decimal, that's 0.045, because we want to make sure our interest rate's a decimal. And then what do we want in the account after all this time? The amount that we actually want to have is 500, which means it actually is doubling. So there's a couple of ways. On the last ones that we did word problems for, in 16.1, we went ahead and solved for n first and then plugged in values. You can do it either way. We can actually plug in values and then solve for n, and I know some of you like dealing with numbers instead of variables. So we're going to go ahead and just plug the values in, and then we'll solve for n. So that means that 500 is equal to 250 times 1 plus r, which is 0.045 divided by 4 to the nth. And I know this can look kind of scary, but I need to get rid of this 250 on both sides. Get rid of it. So that gives me 2 equals. I have 0.045 over 4 to the nth power. I need to simplify that in there. So that gives me 2 equals 1 plus. Now, this up here divided by 4 is 0.01125 to the nth, and then I add it. So I have 2 equals 1.01125 to the nth power. Now, I need to get n out of that exponent, so I have to take the log of both sides. There's no e in here anywhere. So we're going to take the log of 2, and we're going to take the log of this. That allows this to come out here to the front, so that equals n times the log of 1.01125. Divide both sides by the log of 1.01125. And I get n to equal approximately, well, I think rounded it becomes 61.95. So n is about 62 years before it becomes the value of at least. So it'll be a little above, and that's okay. Make sure you write everything down. If you like to take this and solve it for n first and then plug the values in, if that's easier for you, that's fine. I know some of you like numbers instead of variables, so we went ahead and did it this way this time.